Well, grade 12s, welcome back to Cell School. In this lesson, we're going to be looking at three-dimensional trigonometry. However, before we do three-dimensional trigonometry, we need to revise the sine, the cosine, and the area rules. Okay, these are from grade 11 days. And I'm not going to even attempt to go into three dimensions until I've revised what the rules say, when you use the rules, what information would you need to be able to use the three rules, and work with 2 dimensions, that's flatland, and then take it into the 3-dimensional zone in a moment, but also explaining to you what the 3 dimensions are all about. Okay, so now let's have a look at the sine rule quickly. Let's have a look at the sine rule. If we focus on the sine rule quickly, this guy, what does it say? Now, if you've got, watch this, you've got a triangle, okay, and this is going to be A, B, and C. All right. Now, let's suppose I look at angle A and I go to the opposite side. You'll probably remember from grade 11 that the side BC is going to be opposite angle A, and it's normally given a little a. Let's call it A there. The side opposite angle B is referred to as little b, and the angle C is here, but its opposite side we refer to it as little c. So those are this little notation that you use to name the sides. And if you remember how the sine rule worked, it said if you work out the sine of angle A, the sine of that angle, but you divide by the opposite side, that is the same as saying the sine of angle B, now watch that, divided by the opposite side. Okay, but this also equals the sine of angle C divided by little c. That's a rule, but it really at this stage doesn't make so much sense to us because when do we use the rule? Okay, now I'm going to make it a little bit more sensible. That's just a general rule, but let's have a look at a triangle here. So if I, for example, had a triangle like this, and in my triangle I'm given the angle 30 degrees, I'm given that angle 70. So I'm given 2 angles and 1 side. Okay, if I've got that situation, let's put the side there. What I'm able to do, if I've got the 2 angles and 1 side, I can use the sine rule to do some calculations in there. Okay, so you might want to, for example, find the side x there. Okay, and we're going to be talking about this in a moment. So we're going to be revising when you've got 2 angles and 1 side, you can use the sine rule, this rule up top here. The other time that you can use it is if you've got 2 sides. Now watch this. 2 sides. Let's just draw the 2 sides quickly. Okay, if you remember this. So we might have that 3 and that being, say, 6. Okay, but we have an angle, but the angle is what we call, if you remember that, it's a non-included angle. A non-included angle. Now what would that be? Well, if an angle is sitting there, it's included between the 2 sides. But in a situation where your angle is not included, we're going to take it there, it lies over here, for example. Let's say it's sitting over there. In this case, when you've got 2 sides and the non-included angle, we are going to use the sine rule. So when do we use the sine rule? When we have 2 angles and 1 side given, and we're going to use it to find, say, that length x there. In this case, what we're going to do here is we've got 2 sides, but a non-included angle, and you, for example, might want to find that angle there. Okay, so we need to explore this now, and we need to revise it in 2 examples that deal with when you use the sine rule. So if I said to you, when do we use the sine rule? You've got to look for 2 angles and 1 side, like this. There you see 2 angles and a side given, and then we can use it to find little x there, the side x, using the sine rule. Or you could have, for example, 2 sides and a non-included angle, included being in between here, and you might want to find that angle. So these are the 2 scenarios where we're going to be using the sine rules. But now let's explore this a bit. This is still not making much sense at this stage if you've forgotten this, and that's the rule. But now let's put it all together so that you can see exactly what happens. Have a look at this triangle. We want to calculate the length of x there. Maybe to, let's say to 2 decimal places, we want the x. Now let's look at this triangle. What are you given? Well, 2 angles and a side. The moment you have 2 angles and a side, you can use the sine rule. And we want the length of AC, we want the length of x. Now watch how this works. It's very simple. What I'm going to do, now watch carefully. If you've never got this, you need to listen now. I start off with what I want. And what I want is the length of x. Okay, now, if you look at x, that's what you want. We want x. Okay, that's what we want. We want the length of x. Okay, now, that's a side. So, if we create a fraction, we've got to use the other side, which is going to be 16. These have got to be in the same line. Now, let's divide. Okay. Now, what is going to be, let me tidy up that divide line a little bit there. What is going to be at the bottom here? Well, if that's a side, we're going to put a sine there and a sine here. Now, let's find the angles. What angle is opposite that length x? It's 135. Great. Now go to 16. What side, or if you take 16, what angle is opposite that side 16? It's angle A there. Okay, it's the angle A. Alright, but now the question is, how on earth are we going to be working out this value for x if you've got an unknown here? But that's not a problem, because do you know why? Think about it. If that's 135 and that's 24, then angle A, this angle here, is really obtained by saying simply this. If you take 180 degrees, because that's the sum of the angles of a triangle is 180, you subtract the 135 and you subtract the 24. If you do that, you're going to land up with 21 degrees. Okay, so this angle in here is 21 degrees. Now add them up. 135 plus 24 plus 21 will give you 180 degrees. Okay, it adds up to 180. Now, so we know what this angle is here. So that's great. So how do we do this? We can say, okay, fine, no problem. Let me go to blue again. Let's get a nice color here, blue. What we can say is that x over sine 135 degrees, 2 angles in a given side, is 16 over the sine of 21 degrees. So what you have to do when you get a triangle, always look and see, can I fill in some angles? Well, if there's 2 angles, you can get 21 from the sum of the angles of a triangle. You want x, so you go x over the sine of the opposite angles is 16 divided by the sine of 21 degrees. Okay, the sides are together and the angles go together with their trig ratio sign. Now all you have to do is multiply both sides by sine 135, and what would happen is that if you do that, you get this scenario here. Okay, so the sine 135 just kind of pops up. There we go. So, and what did I do? I multiplied this side by sine 135 and this side by sine 135, and those cancel and I'm left with x. So there we go. Now if you work that out in the calculator, just take your calculator, make sure you're on degrees, you just simply plug this in, 16 sine 135 divided by sine 21, and you will come out, if you round off to 2 decimals, at 31,57, and we can just say units there. Okay, great. That is where you have 2 angles and a given side. Okay, and you want the length of x. Okay, now the other version, if you go back here, you need 2 sides and a non-included angle. Let's have a look at this. Next example, have a look here. Notice here you've got 2 sides. There's a side and a side. But the given angle, this angle, is non-included. Okay, it's not sitting where alpha is. Alpha is unknown. This alpha, that theta is unknown, but that's known. So you've got 2 known sides and a known angle, but it's not included. We can use the sine rule. And how we approach it is we're going to want to find, let's say we want to start, I'll say, if you look at the question would have said there, determine or calculate the value of theta and then work out alpha. Okay, now if you think about this, let's have a look here. Well, what do we know? The sine of angle theta divided by its opposite side, which is 23,5, is equal to, now what is the known angle? It's 19 degrees. And what is its opposite side? Well, very simply put, let's have a look at that. That is going to be 12,1. Okay. Alright, now let's have a look here. If we then multiply both sides by 23,5, then sine theta would be, okay, now watch this. If you multiply by 23,5 and you multiply by 23,5, those cancel. And we've got sine theta is basically 23,5, the sine of 19 degrees divided by 12,1. Okay, now let's work this out in a calculator. Just take your calculators, let's work that out quickly. What would that be? Okay, I'm going to put this in the calculator. Open the fraction button there. 23,5 sine 19, go underneath the fraction button there, 12,1, and you land up, you should just check me, you've got 0,632 as a decimal, 632, 301,787. Okay, and if you remember from trig equation days, you go shift sign. Now remember with this thing, okay, what you're going to be doing with the trig equation, if you remember, is you're going to be going theta is equal to shift sign of this number. So let's do it. Shift sign of the number, and what do we land up getting? We land up getting 39,22 if you round that off, okay, to 2 decimal places. But now hang on. If you go back to the diagram, do you notice here that the theta is obtuse? Now what does that mean? It's an angle that's bigger than 90 degrees but smaller than 180. Okay, so it's got to be bigger than 90, smaller than 180. Now if you think about this, okay, that's the one answer that we could have. Do you remember from trig equations you could also go 180 minus shift sign? Now try that. Go 180 minus shift sign. That would give us 180 minus 39,22. That's exactly what we did in trig equations. So I'm not going to add K360 to these guys, simply because we have angles that are only from 0 to 90 degrees to 180 degrees. Okay, so you're not really going to be worried about that. This angle here, 180 minus 39,22, becomes 140,78 degrees. Okay, now this angle is not applicable, it's not valid, because in the diagram the angle is obtuse. So you immediately know that this angle theta is going to be 140,78 degrees. Okay, so if we tidy that up a little bit there, let's fill it in. And there we go. So what do we have here? So this angle is 140 degrees and 140,78 degrees, rounded off to 2 decimal places. Now, how would we get that angle there, alpha? Well, very simply put, this is a triangle, you've got two angles, so you simply say 180 degrees minus the 19 minus the 140,78. Work that out, and alpha comes to 20,22 degrees. There we go. So that's alpha theta there. Now remember, you had two sides but a non-included angle, and you worked out theta. Sine of theta over 23,5 is the sine of 19 over 12,1. You work it out, and remember, you can have two possibilities here. Theta's this, which is not really valid, and theta's 180 minus 39,22, which is 140,78. Remember, sine is positive in the first and second, and that's from 0 to 180 degrees, and obtuse would be over there. Okay, so the answer is that.